when we have y equals a number, we know that that line is, or that's the equation of every single horizontal line. All horizontal lines have the equation y equals a number. All horizontal lines move left to right. All horizontal lines have the same slope, 0. That never changes. So if you have y equals 2, y equals 3, y equals 77, they're all horizontal. They all share the same slopes. Same thing goes for when you have x equals a number. Whenever you have x equals a number, it's always a vertical line, which goes up and down. And the slope of every single vertical line is always what we call undefined. It's undefined because it's 1 over 0. You can't divide by 0. So that's where you get that. That allows you then to go to this. All horizontal lines are parallel to horizontal lines. Reason being, they all have the same slope. Therefore, the exact same thing works with vertical. All vertical lines, x equals a number, will always be parallel to some other x equals a number. Which means horizontal and vertical are what to each other? Perpendicular. Which means then that y equals a number is perpendicular to x equals a number. This, it's not something that you need to make sure you always keep straight, because you could always fall back on, using the point slope form and all that kind of fun stuff. But what's really nice about this, excuse me, is that if you recognize it quickly, it just makes the math faster. And that is a great example to show you why that happens with number 37. I forgot what number it was. It's me faking it. So if I go back and I look at that number 37, I go back right now. I don't know if you guys, are right. Oops. So I go back and look at 37, it says, write the equation of a line that's parallel to y equals 3 that goes to the point 3, negative 5. Well, what kind of line is y equals 3? It's horizontal. What kind of lines are parallel to horizontal lines? Horizontal. What's the equation of every horizontal line? Y equals. What's the ordered pair? Well, it's 3, negative 5. What's the y value there? Negative 5. Go to the next problem. Remember, same thing here, guys. Y equals a number, horizontal line. Horizontal lines are parallel to horizontal lines. Horizontal lines are written as y equals a number. Well, going back here, what's the y value there? Negative 5. If you went the long way, what's the slope of every horizontal line? Okay. So you can do this. Y plus 5 is 0, x minus 3. Well, what's 0 times anything? 0. And then how do you move 5? You can math it. You can math it either way. It works. The idea that you recognize it quicker just makes your life easier. Okay? Just makes your life easier. And that's the idea. What else did you want to look at? Is that the one with the nasty fraction? No, it's not. All right. When you do perpendicular ones, the only thing that changes from perpendicular to parallel is that you have to worry about your slopes. Okay? So when we're dealing with parallel or perpendicular, you always go through the same process. What is the original slope of the given equation? It's negative 1. You okay with that? Obviously, this is a perpendicular problem. So what is the perpendicular slope to negative 1? Well, that means change the sign, flip the fraction. Well, what's the opposite of a negative? And the reciprocal of 1 is 1. And now you have to go through the point y, or 0, 0. So y minus 0 is 1, x minus 0, which gives you y equals x. Do you have a dollar? Is this charity work? You okay? No, I was just wondering because all of a sudden you get the it's let's say it's trying to help you out. First step. What's your original slope?
The original slope is 5.
5 over 8 because it couldn't get away from the buffet.
Thank you, sir.
It's a perpendicular problem. So what is perpendicular to a 5/8? Negative 8/5. Don't worry so much about these fractions. Y minus 4 is negative 8 over 5 x plus 4. Ladies.
And then you distribute.
Very good. Distribute out. You get y minus 4 is negative 8 over 5 times x minus 32 over 5. Remember, even though you got these funny looking fractions, you have a calculator. Use the calculator. It's there for. Use the fraction button. And then obviously then all you have to do is move that negative 4. Well, how do you move a negative 4? You add it back. You get y equals negative 8/5 x minus 12/5. It's tough for me to say, 5th. That's how it works. Don't worry about fractions. Make sure you use the fraction button on the calculator. By the way, we still have calculators. If you have not bought a calculator, make sure you. That's right, you don't have the fraction.
How much did that cost?
15. Excuse you. All right, make sure your names are set it up. Let's talk about graphing.
I hate graphing.
Take long, and then you can continue to try to click things on each other. Remember, like I said, there's a generational gap between us. I don't know if you've noticed that. I'm old, you're not. That kind of thing. I know, who would have thought, right? I act like I'm 12, but I'm really not. So what we're talking about today is graphing. And remember when you're talking about graphing, we're always going to put things in terms of y equals mx plus b. And the reason why we do graphing and y equals mx plus b because it's the easiest way to graph. What happens is you always start with your y-intercept and you walk your slope. That's nothing new. All of you guys have done that before many times. It never changes. The win points, unless I can tell when you're trying to do that, because you're trying to do that. One thing that came up with slopes over the course of the past couple of days, as you guys remember, when you have a slope, let's say y equals negative 2/3 x minus 4, if I want to graph that, where do I start? Excuse me. Where at negative 4? Is it the up negative 4, right negative 4, down negative 4, left negative 4? Down, because it's the y-intercept. Remember, your y-intercept is the y-axis. The y-axis moves up and down.
Yes, sir. Yes, sir.
So you start at negative 4. Your slope then is negative 2/3. Now, remember how we talked about this the other day when we have negatives for slopes? That negative value can be in front, it can be in the numerator, it can be in the denominator. What I want you guys to do is continue to write your negatives whenever you have a negative slope. Did you just hit yourself in the nose? Gross. Apparently you. So what you would do here is always try to float that negative value to the numerator. Because when you do that, then you know your first steps. Remember, slopes are rise over run. If your slope is positive, you move up, then you always go right. If your slope is negative, you'll go down, and then always go right. Yes, sir?
I think I heard this.
You did. This is just review. This won't take very long. So if I start here, I go down 2, right 3, and so on, or up, left. I know. Pace yourself. It's real tough. Really, 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 really tough. Quite honestly, the craziest stuff that we see with this, especially as we get into geometry, is that you'll have to do multiple steps just to get y by itself. Right? That's really about as goofy as any of these things become. Having to move some stuff around to get y all by itself. Right? For example, let's say we have the following equation. 2x minus 4 is 8. Oops, sorry. Is 2y. Do it. Anyway, when you start working with these things, always get y by itself. Does y have to be on either side? Does it matter? It doesn't. Could you rewrite it and put it as 2y equals 2x minus 4? It's fine. Normally people do that just because they're used to seeing the y on one side. Now how do you get y by itself here? What do you divide by 2? Everything. Very good. That was why I wanted to make sure you guys remembered that. So you get y equals x minus 2. What's the slope if all you see is an x? If my slope is 1, which way do I go first? How many? Then where? Go up 1 over 1 and so on. What happens if you have the following equation? Trying to think one off the top of my head. I have something like that.
Oh, that's easy.
Will the two of you please behave? It's always the girls in the middle of the room. Jerks. Negative 5y minus 15 is 3x. What are you going to do first? Add the 15. Add the 15. Yeah, it's going to get y by itself. Very good. Remember, your goal here is, guys, to get the y value by itself. So we start by moving everything else. How do I move a negative? Then what? Divide by the negative. Okay. So you get y equals what? Negative 3 over 5. Very good. Now, the reason, herein lies again why I want to put that negative value in the numerator, just because you know now for certain your first step is to move down, and then you're always going to go to the right. It's just one of those little catch-alls that I try to do to make sure you guys catch it. See that? Okay. That was called proper wait time. You just got awkward, so stop waiting. How do I graph that?
I know what that is.
What is that?
Oh, it's a line.
It's a line. Very good, ladies and gentlemen. It's a line. Way to go. Yes. Vertical. Now, vertical line. But, hold on. What do I have to do to get the x by itself?
Then I
Divide by the negative. Good. So your vertical line would be at x equals -3. So on a graph, it would be. Do you think we can make this any more difficult?
Wait, how did you move that negative?
Divide by -1. Multiply by -1. Either one.
Oh, okay, thank you.
You're welcome, Mr. Student, sir.
There you go. There you go.
These are the 8 problems that are at the very beginning of the worksheet from the other day. Do these on one of the graphs that I gave you. Those are the 8 that you have. I can make it 16 if you want. Why don't you just take a picture of it and have it next to you? I could keep talking and annoy you for the next 20 minutes and then let you try to do these 8 problems. To keep talking and annoying you? All right, let's do some more problems for Joe, ladies and gentlemen. All right. Joe, give me the equation. I'm annoyed by you already.